Recall from our discussion on functions, we mentioned that a function is a mathematical rule. So let's say this is a function f. All it does is it takes in an input, let's call it x, and it churns out an output f of x. Now, what we will do here, we will consider another function. Let's call it the function g, which will be another mathematical rule. And what if we are to feed in the output of the function f as the input, and this is going to give us a new output. So what we have done here is composition of functions. So if we have the input and the output, so we feed in x to our first function f and gives us the output f of x. Then we take that same output and this time feed in as the input to our new function g, and this is going to give us the output g of, you remember, so this x is generally the input. So in our second case, so our input will be f of x. So this is called composition of functions. So this is equivalent to saying g o f. So this is the g composition of f, and this is acting on the original input x. So in another way, we can ask the same question, like what is the relationship between the input x and the final output? So this is given by this particular composition of functions. We can also reverse the rule. So what if we feed in the input as g of x, then the output will be in terms of f. So this will become f of the input. So the input is g of x, and in that case we have f o g of the function x, of the value of the input x. Let's consider a few examples. So let's say our function f of x is defined as x squared, and our function g of x is defined as 2x plus 1. So we'll try to find out f composition g and also g composition f. So let's start with the first one, f composition x. In order to define this, this is also written as f composition g of x. So this can be broken down as f of g of x. So our g of x is given by, so we just replace the value of gx here. So this is 2x plus 1. Now let's say we have f of x given by x squared. So if we replace x with 1, then f of 1 will become 1 squared. All we have done is in place of x we substituted with the value 1. If we have f of 3, so this will become 3 squared. So now instead of numbers, if we simply replace with some variables, or let's say a constant a plus b, then all we have to do is in place of x replace it with a plus b. So this will become a plus b squared. So in our case, we have f of 2x plus 1, so this will become 2x plus 1 squared. We know that f of x is x squared, so what we have done is, in order to find out f of 2x plus 1, we have replaced x with 2x plus 1 squared. So this is the value of f of g of x. Let's go to the second one, g of f of x. So this will be same as g of f of x. So we'll substitute the value of f of x here. So f of x is given by x squared, same rule. So we have g of x, which is given by 2x plus 1. So we have 2x plus 1. So instead of x, we'll replace it with x squared. So this will become 2x squared plus 1. So this is the value of g of f of x. Now clearly we can see here that f of g is not equals to g of f. So they do not commute. So let's try out 3 more problems. So we are provided with two functions, f of x and g of x. So we need to figure out the values for each of the composition. So let's begin with the first one. So we have f of g. In order to find out this value, so we will consider f of g of x. So this can be also written as f of g of x. So we have f of, so g of x, so let's replace the value of g of x with 2x minus 3. So this will be equals to, so we have f of x given by x squared plus 3x plus 1. All we have to do is, in place of x, we'll replace it with 2x minus 3. Everything else remains the same. In the sense, the structure will remain the same. So let me write it in this particular fashion. So we have x squared plus 3x plus 1. The structure will remain the same. All we have to do is replace the value of x with 2x minus 3. So I'm going to leave the answer here. You can go ahead and expand this, but this is how we can find the final value of f of g of x. Let's try it out with g of f of x. So this can be also written as g of f of x. Fine. So this will be equals to g of, so what is f of x? So f of x, we simply replace it with x squared plus 3x plus 1. So this is equals to, so now we have to find out g of something. So we are given with g of x, which is 2x minus 3. So this is 2x minus 3. The structure must remain the same as g, the original g function. So in place of x, we'll replace it with x squared plus 3x plus 1. Right. So this is the value of g of f of x. Then we find out g o g. So g of x. So this will be equals to g of x. So g of x is 2x minus 3. Now what we'll do, we'll take the original g of x. So this is 2x minus 3. And in place of x, we have to replace it with 2x minus 3. So this is the composition g of x. And finally, we have f of x. So this will be equals to f of fx. So we have f of fx. So fx is given by x squared plus 3x plus 1. So what we'll do, we will rewrite f of x. So this is x squared plus 3x plus 1. And instead of x, we have x squared plus 3x plus 1 plus x squared plus 3x plus 1. So this is the value of f of f. So let's try out a few more problems. Problem number 2. So we have two functions, e raised to the power of x squared and e raised to the power of 2x. These two functions are formed from the composition of two functions. So we need to determine the functions and their composition. So let us begin. So let us suppose, by looking at this particular function, e raised to the power of x squared, let's make an educated guess. Suppose the function f of x is given by x squared and g of x is given by e raised to the power of x. Then we'll try to find out f of g. So f of g of x, that will be equals to, we have f of g of x. So g of x is e raised to the power of x. And we have f of x is given by x squared. So in place of x, we'll replace it with the exponential function e raised to the power of x. And this gives us e raised to the power of 2x. So we have obtained this particular composition. So e raised to the power of 2x is the composition function f of g of x. Then let's find out g of f of x. So this will be equals to g of fx. So our f of x, this is given by x squared, and we have g of x, which is e raised to the power of x. Now instead of x, we'll replace with x squared. So we have e raised to the power of x squared. So this is the other function. So this is the composition g of f of x. So yeah, so this is how we can break out the function. So this needs a little bit of guesswork, but with practice, it will come easily to you. Let's do one more problem. Problem number 3. So suppose a composition function is given by h of x, which is give a natural log of sine x squared plus 5. So we need to express this as a composition function. So we begin by analyzing this given function, and like in the previous problem, we'll try to make some guesses here. So we have, let's note down the function first. So let's call the outermost function, which is the logarithmic function, and represented by f of some variable u. Then this becomes natural log of u. So this is a outermost function. Then we come to the middle part, which will be sine x squared plus 5, but we are going to represent it with g of, let's say, the variable v. So this will become sine v plus 5, because there are 3 components here. So we also need to take care of this x squared part. So let's call it p of x. So this will be x squared. Now let's see if this, let me write it down first. This is the middle part, and this is the innermost part. Now let's see if our guess has been correct or not. So all we have to do is find the f of g of p. So this is a composition of 3 functions. So this can be expressed as f of g of px. So p of x becomes the input then. So this will be now f of g of px. Okay, fine. So we have f of g of px. So p of x is x squared. All we have done is replace the value of px. Then we have f of g of x squared. So we have g of v, which is sine v plus 5. So this is sine v plus 5. So to find out gx squared, replace the value of v with x squared. So we have sine x squared plus 5. Fine. Then we have f of sine x squared plus 5. But f of x, we assume that this is natural log of the value u. So u will be replaced with sine x squared plus 5. And this gives us indeed the original function h of x. So this is how we have broken down the given composition function into its constituent functions. So we have the function f of x given by x squared plus 8. And g of x given by 3x cubed plus 1. We need to find out f of g of 2 and g of f of 1. So let's begin with f of g. So we'll find f of g of x first. Then we'll substitute the value of x with 2 at the end. So f of g of x will be f of gx. So we have f of gx. So gx would be 3x cubed plus 1. So we have f of x given by x squared plus 8. So in place of x, we replace it with 3x cubed plus 1. Then we now replace the value of x with 2. So this will give us 3 times 2 cubed. So that's 8 plus 1 whole squared plus 8. So this will be equals to 633. So this is the value of f of g of 2. Then we find out g of f of x. So this is equivalent to g of fx. So g of fx or fx is given by x squared plus 8. So this will be equals to, so we have g of x, which is 3x cubed plus 1, and in place of x we have x squared plus 8. So this is equals to, we'll not expand this, instead we'll try to find out the value of g of f of 1. All we have to do is replace the value of x with 1. So we have 1 squared, so that's 1 plus 8 whole cubed plus 1. So this is equals to 3 times 8 plus 1 is 9. So we have 9 cubed plus 1. So this is equals to 9 cubed, 2188. So yeah, so this is the value of f of g of 2 and g of f of 1.